In the last video, I described basics of how the infrared grid work using IR emitters and detectors, feeding them in through a PLD and having two rows of LEDs identify where along the infrared paths I'm blocking with my finger here with another object. So like I said before, when I move my finger around, you can see the LEDs changing to represent where the object is blocking the infrared beams. Since then, I've written a software program. I've fed the data from the grid via this USB cable into the computer, and I've developed a little graphical representation of the grid so I can show that the computer can understand where exactly the object is on inside this grid. So let me demo that real quickly. Kick off the program, and what pops up is a graphical representation of the infrared beams. The circles are emitters, the squares are detectors, and the lines between them are representing the infrared light that's passing from the emitter to the detector. The solid lines are showing that light is actually being received by the detectors. And in the background, you can see the line read bytes followed by a couple of numbers, and that's showing the actual data that's being sent across the USB cable to the program. So now if I do like I did before, where I block a beam or two beams, for example, right now I've blocked the two center beams. You can see it on the two LEDs that have turned dark on the breadboard, and you can also see in the graphical representation the middle lines have gone dark in the program. So as I move my finger around, you can see the graphics changing, just like you can see the LEDs changing on the breadboard. And this is working pretty much in real time. The receiving of the grid data is happening just about every 10 milliseconds. And let me demo again with a little pinball rolling around. You can see it updates the screen pretty quickly when the ball's rolling around the playfield.